Let us continue with the same session on making of equations. And as I told you, it is a very important concept and you can solve almost every question of time and distance by using this concept. In the previous session, you saw we could make equations by using total distance, total time. Um, there is another variable which we left out for the last session, which we will look at in this session, that is making equations by using difference of time. Let us see one question to understand how to use difference of time for making an equation. Anuj travels from his home to his office at a speed of 10 km per hour and is late to his office by 10 minutes. The next day, he increases his speed to 12 kilometers an hour and reaches his office early by 10 minutes. How far is his office from his home? So, this is a question. How do you make an equation? Now, the first thing that you need to understand is there are two cases here. Case 1, when the person travels at 10 km per hour to his office, and there is a case 2 when the person traveled at 12 km per hour to his office. Obviously, if a person travels the same distance at two different speeds, there is bound to be a time differential in both the cases. That is exactly what has happened here. The person traveled at 10 kilometers per hour on the first day, he travels at 12 kilometers per hour on the second day, which causes a delay. And what is the total delay equal to? The total delay is equal to 20 minutes. How do you arrive at this 20 minutes? He is 10 minutes late on the first day and he is 10 minutes early from the standard time on the second day. So for example, if the standard time is 10 o'clock in the morning, so on the first day he reaches at 10:10, on the second day he reaches at 9:50. The difference between 9:50 and 10:10 is 20 minutes. So obviously the 20-minute time differential has been caused because he traveled at 10 km per hour, he traveled at a slower speed and on the first day, and he traveled at a faster speed on the second day. So therefore we have this equation, total delay is equal to time traveled at the slower speed minus the time traveled at the faster speed, which is equal to, if you write this in arithmetic, if you write all the numbers for the given values, the delay is 20 minutes, which converted into hours becomes 20 by 60, is equal to d by 10, because again we have the variable time which is converted into distance upon speed. So 10 is the speed, d is the distance, d by 10 is the time traveled at the slower speed, minus d by 12, which is nothing but the time traveled at the faster speed. And if you solve for d, you will get 20 kilometers as the answer. So let us look at another question which is based on making an equation by using the difference of time. A bus starts from Bhopal and travels to Siuni at a speed of 60 kilometers per hour. A man traveling in a car at a speed of 80 kilometers an hour starts from Bhopal an hour later and travels to Siuni. If both the bus and the man reach Siuni at the same time, what is the distance between Bhopal and Siuni? Well, there is a difference of time generated. The person who went in the bus, he took 1 hour longer than the person who went in the car. So the difference of time has been generated because the same distance from Bhopal to Sivni has been traveled by the bus as well as by the car. So what's our equation? As you see the schema, Bhopal represented by B, Sivni represented by S. The difference of time is that of 1 hour, and 1 hour must be equal to the time traveled at the slower speed represented by Ts there, minus the time taken at the faster speed represented by Tf. Again, rewriting the above equation, Ts is replaced by the distance d divided by 60 minus the tf, that is the time taken at the faster speed, is replaced by d divided by 80. On solving this equation, we'll get the value of d as 240 km. So with this we come to an end of this session. If you have any feedback or if you have any query, please feel free to contact us at studentservices@pfindia.com. Thank you so much.